Hello. Oh, I believe it's working. Hi, everyone. Thanks for joining today. It's a pleasure to be here. I came all the way from Portugal to be here today. I would like, first of all, to thank besides Ahmedabad for the awesome organization, for the awesome event. My name is Paulo Silva. The best part of my daily work is searching for vulnerabilities. I do it either on pen testing or ethical hacking. But my background is in computer sciences. I started as a software developer. For 15 years, that was what I did. So 15 years is plenty of time to do all sorts of mistakes. Then I shifted to security. I started as a OWASP volunteer, and I've contributed to several different projects. Nowadays, I'm co-leading the OWASP API Security project, and I've co-authored the OWASP API Security Top 10 that you may have heard about it. I don't have a real agenda for today. I want to share a story with you about the security vulnerability, but we should go back a few years in time. So in 1989, Sir Tim Berners-Lee proposed the HTTP protocol. In the next year, he wrote the first browser and the first HTTP server. On the next year, he also created the first website. This is how it looked like. I believe that he was far from imagining how we would use the HTTP protocol and the web technologies as we are doing nowadays. You can still access the first website using your modern browser, and this is how it looks like. In 1993, the first browser or web browser for non-tech people was released. And in 1995, Netscape came up with the Navigator. It was a more polished web browser. And in the next year, they added support for a scripting language. And we should welcome, in 1995, JavaScript. Meanwhile, some folks were working towards making dynamic pages computed server-side. I'm not sure whether PHP was the first programming language allowing to do it, but it plays an important role in the evolution of World Wide Web. Recent stats say that PHP is still powering 70% of the known websites. What I'm going to show now is pretty much what powered the .com bubble. So we have clients. Back in the days, it was a web browser. It issues a request that gets through the server, that picks the file you want and returns HTML. Then the client parses the HTML and looks for additional resources the client should request, such as JavaScript. It goes to the server, picks the JavaScript. It could also pick style sheets. And then if the user wants to navigate to another page, like the login page, then it has to go to the server, and the server gives you back the computed HTML. And then the client has to do all the heavy lift work to pick up the JavaScript, style sheets, and stuff like that. If you want to really log in, send your credentials, the server is the one responsible to compute again the HTML with your username on it. So when pretty much every company had already a website running, mobile apps became the new thing, okay? And they had to start developing web applications. Web applications are a bit different from websites. They have their own presentation layer. But the goal was to offer a seamless experience to website users. So the info you have available on the web should also be available on your mobile app and the other way around. But as I said, mobile applications, they have their own presentation layer. They don't use HTML, CSS, or JavaScript. At least back in the days, they didn't use it. Nowadays, you have modern frameworks that allow you to develop using web technologies. But the way they work, they just need data from the backend server. So they just send data to the server, and they get data. JSON is the most common format you get data from the server. So if you want to log in, you post your credentials, and you get probably an auth token from the server. Then if you want the user profile, you just request the profile with your authentication token, and you get data from the server. The same for posts. So as you see, there's no HTML coming from the server to the client. And then I know that nowadays everyone is focused on AI, but IoT is still a thing. So we had before web browsers as clients, then mobile applications as clients, and now we have everything as a client using the same technology, the same thing that was built in 1989. Okay, the protocol remained almost the same until the HTTP2. No major changes were added. So with IoT, most of the devices, they don't have a presentation layer. They don't have a graphical user interface. They just exchange data with the server. They pull data and they fetch data. And the data may be created by a mobile application, like when you set up your smart bulb at home. Probably you're going to use a mobile application to do it. But then the bulb should pull the data from the server. The same is true if your bulb has the capability to collect and send to the server the power consumption. Probably you want to see that data on a web browser, on a very nice and fancy dashboard. Even some devices, they have same capabilities. Both a mobile phone, a tablet, or a smartwatch, probably all of them have tracking capabilities. They can collect your location, and probably you want the way this data should be treated server-side is the same. So you don't want to have to implement the same logic, the way you treat the data, on 3 different applications. You want to treat it the same way on a central location. And then we should welcome APIs. APIs allows us to decouple the presentation layer from the business logic and the data layer. So they work pretty much like mobile applications. They don't care about presentation. They don't care about HTML, CSS, and JavaScript. It's all about data. So you can get the device config from the server, and you get your data using the JSON format or any other data exchange format. You can send data to the server, and you get back data. You may, on the server side, you should look at this as a black box. Although you may be sending requests to the same server, internally, probably you're hitting different APIs. They are very specialized, okay? Even they may require external or third-party services. For instance, to enhance some data that you send to the server, they need to contact Google Maps to collect additional data on top of that information. Even the server, while your clients are idle, they may interact with other services to collect data or to do some heavy work while you're not using the server. Of course, with the APIs playing a central role, web application development has changed. Nowadays, we have companies are likely to have different teams to handle the front-end development, the presentation layer, either for web applications and mobile applications, and specialized teams on the server side. Probably some of them, they are specialized on APIs, and they are just developing APIs. So with the advent of APIs, the web applications right now, probably if you look on the network, they're going to get the homepage, they're going to hit the slash, and they're going to get a small HTML file, a very simple HTML file. Probably the second request you're going to see is a bundle.js, a JavaScript file. And after that, all you're going to see on the network are just fetching data or pushing data to the server, because all the presentation layer is within the bundle JavaScript. Modern web applications are built using modern web frameworks like React, Vue, Svelte, and stuff like that. Even web applications, they don't have to use a single API. They can even directly contact third-party APIs. And this is what you're going to get if you look under the hood. with APIs popping up everywhere, security folks start looking and finding security issues on them. Also attackers, they shift to APIs because they are easier to attack because the interface is predictable. It's well-defined, both well-defined and predictable. So the learning curve is really short. And because of that, we decided to create an API-specific top 10. We learned from the past that we cannot let the technology advance too much before starting teaching developers how to address security on that technology. We start seeing some security issues that were really common back in the days on web applications. They start popping up on APIs. I'm talking specifically about what you probably know by IDOR, Insecure Direct Object References, that we called broken object level authorization on APIs. It's pretty much the same thing. It was really common back in the days on web applications, and right now it's really common on APIs. So we should talk to API developers about that, so that they can address it. And probably we should also fix some misconception about what insecure direct object reference is or what broken object level authorization is. This talk is not about the API security top 10. If you want to discuss it later, don't be shy. Come to me and let's have a chat about it. But it's important to keep in mind that APIs mean data. This is, I'd say, the reason number one why attackers go after APIs, directly after APIs. Because someone said that data is the new oil. And to be honest, on the digital economy, in fact, it is. We heard about how much does it cost a data breach. So if we have to compromise, if we are looking after data, APIs are a good candidate where we're going to find loads of data. And with this, we arrive to the second part of this talk. HR 49, when we have spare time while we're not pen testing, we do some research, look for bugs on other companies. It's not exactly bug bounty, but several companies, they have responsible disclosure programs. So usually we do it. And we decided at some point to do it on car manufacturers. See how they handle, how they secure their digital assets. So I know they are worried about car safety. We decided to see how they handle security. And Porsche was one of that car manufacturers we looked at. They have a responsible disclosure program, so we focused on the in-scope assets. We heard it already today. If we want to hack something, if we want to break something, better knowing how it works, how it was built, and how it works. One of the assets in scope was this Porsche Experience website. From the user perspective, it allows to booking, tracking days, manage your bookings, create a virtual garage, but also manage invoices and stuff like that. So it is likely to have enough data. And we decided to check under the hood. We find out this is a single-page application. So the same workflow we saw before. It just fetches the home page, the slash endpoint. It gets the bundle, and then it starts fetching data from a GraphQL API. We also heard about GraphQL today already. I'm not going into depth into GraphQL. That is not the point here today. But while looking at the traffic to the GraphQL API, we saw something strange that called our attention. We saw that on a single API request, they included the authentication token, or the authorization, the auth token, twice. It was available both on the, as a cookie and in the app authorization header. So if you're familiar with web development and how the web browser works, it's totally different. It's a game changer when you add the auth token in a custom or in the authorization header. Because if it's on the cookies are managed by the web browser. The web browser automatically adds the cookie to the request. So we came up with the idea, so what happens if we don't provide the app authorization header? Does we get it automatically, the cookie automatically added to the server? And that do we get the same resource? And replaying the request without the app authorization, just with the auth token in the cookie, we got the exact same response. That means when the app authorization header is not there, the server or the API is going to look for it on the cookies. So we came up with the idea, which is not that brilliant, that if we create our own page and we issue a request to the GraphQL API, if the user is authenticated, probably we're going to be able to fetch the data. So this is called cross-site request forgery. We were not sure, but we could just ask the API whether it was willing to fulfill a request started from our page. And this is what we have here. From a different origin other than Porsche.com, from my own server, a page specially crafted for this POC. The API replied successfully with a 200 OK, and the access control allow origin and credentials in the response. So the API was willing to fulfill our requests. So there's another question. As I said before, cookies are managed by the web browser. I mean, whether they are included on the request. So the next question is the web browser willing to add the cookie if we start the request from a different origin? And that we can answer looking at the cookies settings. And the GWT token is the one we care. We can see that the HTTP only flag is set to false, which is not a good idea. But the one we really care about is the same site, which is set to lax. The same site is a security mechanism because cross-site request forgery attacks were really common on the web. Web browser vendors starting adding some security features to mitigate some of the risks. And the same site is one of those cookies attributes, security attributes, that controls whether the browser should automatically include the cookies on cross-site requests. And lax means no. So we could give up or try harder, and we used to say that hackers or bad actors, they're going to always try harder. So we know that the cookie won't be automatically included on our cross-origin request. The point is, we just need a way to make Porsche.com or a subdomain of it to make the request. And we know that this is not a typical feature. This is not something that we should expect to find on the website. But then there's cross-site scripting. I'm expecting that most of you are aware of cross-site scripting, but just to put everyone at the same page, cross-site scripting allows you to inject JavaScript code that is going to run on the page as it was there before, as it was code written by the developers, okay? And we found one on Porsche.com. In fact, we found two cross-site scriptings. The second one was content.eu.porsche.com, and there was a third one at campaigns.porsche.com. I brought this today because not always we can not always target the API directly. Sometimes we have to abuse or exploit an API client to target or to reach our goal. So I brought this because sometimes you have to manage two different things to achieve your goal. And this, we were not looking specifically for a vulnerability. We had an attack scenario in mind. Our goal was to fetch data, access other users' data, no matter what. So we first looked at the API. We found a way to move forward, and then we ended up needing to exploit the web application to target the API. And we decided to move forward with this cross-site scripting. Campaigns.porsche.com sounded catchy for a phishing campaign, because this was our scenario. We know that if we deliver some malicious URL to a victim, and it is a Porsche experience user, we're going to fetch the data. So right now our goal is to, let's say, create a phishing campaign, send the malicious URL. Our victim is a Porsche experience user, and he has a valid session. And what we want to accomplish is to make an API request, fetch his personal information, and exfiltrate it to a remote server. So this is the starting point. Without the cross-site scripting on this parameter, this was just to confirm that the cross-site scripting was there, just popping up the same alert we have here. But we need more logic to fetch the data from, make an API request, and exfiltrate the data to a remote server. So it is not practical to put all the logic on the URL. So we decided to go with a loader. This is just a simple script to load a second script from a remote location. So we create a script element, we set it to our remote server, to a file that we put on a remote server, and then we append the script to the document body. This means that the browser is going to load the script and execute the code in there. To avoid some issues, encoding issues in the URL, we did the common technique, based 64 encode on our payload, and then the payload, we decode it first, and then we pass it to the eval function to read and execute the JavaScript code. On the remote server, this is the file we put there. First, we prepare the query to get the user details, the authenticated user details. We fetch the data. We actually make the GraphQL query. And then we send the data to a remote location. Then we were kind enough to redirect the victim to the home page to make the attack almost unnoticeable. And then we finally used AI. We asked ChatGPT to write a catchy phishing email. He said no, and then with a few other prompts, we got a catchy email from ChatGPT. We just had to add the URL with the campaigns Porsche.com. If you want, you could even hide the payload to make it even look nicer. And this is the POC we sent to Porsche. So right now our victim is really excited to have a Porsche track experience. And we got happy with their data. So there's nothing fancy here. The point is we were not looking for a specific vulnerability. We discussed it earlier today, doing recon, know the assets that are in scope, how they work, how they were built, and then make your own scenario and try your chances with your scenario. So this is what we did here, and we accomplished our goal. This is fixed. So there's nothing new here. I've put together some resources for you. On the left side, you have API resources from OWASP. You have goats and stuff like that that will allow you to learn API security, several OWASP cheat sheets that are relevant for API security, how to develop, how to secure, and some coding guides. On the right side, you have general resources to allow you to better understand the HTTP protocol, how it works, how the cross-origin resource sharing policy works, and also to understand the different API protocols, REST, GraphQL, RPC. At the end of the day, they all work the same. They have specific features, but at the end of the day, all of them work on top of HTTP. Some of them, they can work on top of other protocols, but at the end of the day, all of them work on top of HTTP. Then you have several GraphQL articles and specific issues. You also have a specific GraphQL cheat sheet. And at the end, on the right side, you have Mind API. If you're going into API hacking, it's a good resource that helps you to cover the OWASP API security top 10 from an attacker perspective or a security guy perspective. This should make your life easier to use your mobile phones and get the resources